Welcome, everyone. And Pat has definitely given us a broader national and policy level landscape for us. But AI literacy clearly from all the speakers today, it's no longer optional. It is actually as fundamental as reading, writing, critical thinking, everything. And our students won't just use AI. AI is literally shaping them, right? So it's our job to ensure that they remain authors of their own thinking, and as well as not just treat them as consumers of education, right? So it's not like a machine output education that they are consuming, but we need to treat them as producers of information, producers of innovation. I think that's what is happening. So if I have to start this panel with a question to all of you, if a student graduates today without understanding AI, are we preparing them for the future or for the past, right? And I was noticing President Washington walk by, and he said you should talk about these two things. I was just updating him on something. How many of you actually know that Virginia now officially has a high school data science class? Please raise your hand. 2 people. That's great. So back in 2022, I was tasked to lead the charge for the first ever high school standards of learning for data science, followed by a curriculum and a high school class, which is now in 132 high schools all across the state, the highest in the country, if you did not know that. And also, it gives the 4th math credit. So we have about 6,000 kids that are taking it. These kids are all knocking doors, the community colleges and higher education, 4-year higher education. So if you did not, I didn't see a whole lot of hands come up. You all have kids in high school, so now you know. So look for this class. That's one thing that I wanted to tell you that was developed by a big team, and this is back to Pat. K-12 is always an afterthought. Something happens at the university, and then the universities tell, hey, K-12, you should do this. It did not happen that way. It actually grew ground up. K-12, higher ed, community college partners, everybody came together and built it ground up. Now, what's happening right now? Part 2 of that class is being created. It's going to be data science in the age of AI. I know Robert Brandon is a president of one of the community colleges here. That is going to happen. So what we're going to do now is to explore this whole idea, and we're going to invite the 5 distinguished panelists here, and right there. And so let me just call the panelists, and then I'll ask them each to speak, introduce themselves. Vadim? Is Vadim here? There. Vadim, come on over. Vadim is an associate professor, systems engineering, program director of MS in AI, College of Engineering and Computing. Missy Cummings? There, okay. Professor, director of MARC. She'll tell you what MARC is all about, and College of Engineering and Computing. And then we have Janus. Oh, you're also here. Great, okay. So we got Jesse too, Janus, and Nancy. Come on over, CHD. So these people are all from, Jesse is from the College of Humanities and Social Sciences, and then Janus is from College of Public Health. So these are all, and I'm from the College of Science. So you have like multiple colleges here, and and they are here to actually talk about some of the really cool things that they're actually leading. And the second thing I wanted to share is I actually am the only higher education member in the state of Virginia that reports to 2 secretaries, the Secretary of Education that helped to create the data science class, and the Secretary of Labor. I was asked to give you a message. I know Microsoft is sitting here, but Google is also another little company, as you all know. And Google has signed with the Secretary of Labor's office, Grow with Google certifications, 10,000 of them. If you are a Virginian, you can go to Virginia Has Jobs right now, and you can actually sign yourself, and there is actually a course that you can actually take. It's AI certifications through Google. It's called Grow with Google. Okay, I'm sure Microsoft has a lot of things also. But at Mason, we actually have a lot of things going on. So this panel actually has somebody who's going to talk about MS in artificial intelligence. Somebody who's going to talk about responsible AI graduate certificate. Another person who's going to talk about a certificate in AI and health. Someone who will talk about the work of Mason Autonomy and Robotics Center. and AI literacy in the College of Education and Human Development. So as I call on you, I'm going to ask you to introduce yourself for 2 to 3 minutes, and you can talk about your program, but also tell what AI literate citizen means to you in that program. So Vadim, let me start with you.
This works? Okay. My name is Vadim Sokolov. I'm program director of Masters in AI. So it's a full-featured master's program with 30 credits. So for us, AI literacy means it's a technical program. It's a program out of engineering school. So we teach students how to govern those systems. So we have ethics course, for example. We have business course that teaches them how to manage those systems. We teach students how to run those tools. So we give them technical background. It's math, probability, optimization, so all the technical tools that you need to understand how those things work, how to tune them, how to set them up to work correctly. And if something goes wrong, they also should understand why it goes wrong and how to fix them. And deploy. So deploy means they need to understand how to scale those systems, how to integrate them into the existing infrastructure, into the existing workflows. So all of those things, that's what we teach in the program. So govern, run those systems, and deploy. And again, we have, it's mostly in-person program in Fairfax campus. We have some online courses. The reason it's in person, it helps students to connect to faculty, to connect to each other. We have a large chat room where students exchange job postings. They talk to each other, exchange ideas. So that's who we are.
Thank you. So technical, and I like the ethics piece. That's awesome. So Missy.
And it's not a second-class citizen. It's a required course in the program.
That's great. Fantastic. Missy.
Yes, thank you. Thank you for having me here today. I'm the director of the Mason Autonomy and Robotics Center. Other ways that you have heard this referenced is embodied AI, physical AI. Robots need a lot of AI to move about in the real world. And so in Virginia, we are the only school that has a PhD in robotics. And it just recently started, so it's an in-person program. This is just the nature of robotics. You got to be there to actually work on the hardware systems. If you get a chance to ever look up at the 3rd floor here, there's a big robotics space, and there's a big robotics, the Marx Center on the Fairfax campus, and a new one just opened up on the SciTech campus. So we're everywhere. As far as what does AI mean, AI literacy mean, I'm going to say this. If you don't remember anything I say, AI doesn't think, it doesn't reason, it doesn't know, it doesn't understand, it doesn't have imagination. It just, the kind of large language models or generative AI in general does next token prediction. It is a statistical model. It is not, we are not even close to sentience or general intelligence. What we really need, and it's becoming clearer every day, is more structured human-AI collaboration. AI really cannot do it, whatever the job it is, without humans somewhere in the loop, and humans need AI to actually help them potentially work faster or more complete, help develop code, but not exclusively rely on LLM-generated code. So I think that even though I think there's way too much hype right now about what AI can do, I think that there's a huge untouched space in human-AI collaboration, and I'm hoping to inspire people to get into this space because the sky's the limit.
Wonderful. Thank you for the human perspective. That's very, very important. So, and that's where design thinking comes in, also human-centered approach to problem solving. And so you defined what artificial means. So this is great. So thank you. And so let's move on to Janusz.
Right. I am Janusz Wojtusiak. I am Director of Health Informatics Program here at Mason. We have undergrad, master's, PhD concentration in health informatics. I've been asked to come here because we just opened a certificate in AI in health. So it has AI in name, but we've been actually doing AI for much, much longer. In our master's program, we have data analytics concentration that really is machine learning using electronic health records, claims data, other data sets, healthcare data sets. We have, certificate in data analytics, which is essentially doing the same. We teach undergrads, we teach other students do the same. When you look at AI literacy, to move to the other question, I'm kind of too academic because I change my mind every other day what it actually is. And I think it depends. If you're looking at the general public, if you're looking at undergrads, high school students, it's something else. When we teach even undergrad students or master students or PhD students, it's something completely different. And we really need to distinguish between being end users of those, let's say AI systems and being able to nicely chat with all the chats. And it's something else to have this deep understanding what this stuff actually does, what are the limitations, how they actually work. And this is what we try to do in our programs. We don't really teach students how to chat with chat, right? I mean, they're actually much better than I am in doing those things, and they're much quicker to learn. What we try to teach them is what's the underlying theories, what is the intuition behind how they work, what are the limitations, what those things are good for, and what they're not. So what that literally means, it really depends on the context.
Wonderful. Context. Context always matters. And as you're hearing, you have master's degree, PhD degree, a graduate certificate. What's probably running in your mind is how long will it take me to finish this and how many credits it is. And I know you're, and then how much does it cost, right? So I'm sure you'll have time to talk to them. But we live in an age of like, I want to get that very quickly, right? So digital certifications or digital badges leading to micro-credentials, leading to courses, leading to degrees and things like that. So I now invite Jesse next to speak about what's going on in your house.
Sure. Yeah, thank you. I'm Jesse Kirkpatrick. I co-direct the Mason Autonomy and Robotics Center with Missy. I also have a joint appointment in the Department of Philosophy and the College of Humanities and Social Sciences. So I really want to talk about two things. One is the importance, which has been recognized throughout the remarks and the structure today of social science and humanities within the kind of AI space. And I'll tell you two things that we do. So the first is that that the MARC has a responsible AI graduate certificate, right? That looks at the reliable and responsible dimensions of artificial intelligence. It's kind of a mini master's, and it can be completed both online and in person. And it's a really excellent bridge between the kind of technical dimensions of AI and what we call the socio-technical or kind of humanities, social sciencey stuff related to AI. The second is that one example of this at the undergraduate level, which we really haven't talked about yet, is the College of the Chess has and the Department of Philosophy has an ethics and AI minor, right? And again, the minor is rooted in the kind of socio-technical inquiry that is really important when we think about what the implications are of AI, how to design, develop, and deploy AI well, right? And what might be the risks that need to be managed and mitigated. So in closing, I would say that the AI literacy, I think, includes, to be sure, the technical dimensions that we've been discussing, but also includes to be literate in what those socio-technical dimensions are, what the societal implications are, the legal, the policy, the ethical. And I think that, to recognize that, we can then move from AI literacy to something like AI fluency.
Wonderful. Thank you. Thank you for that. And so you saw a lot of how technical expertise is being shared. And also, you heard about code.org. Just last month, I used to be at the National Science Foundation, where Amarda also worked with me. And they just made a huge award to code.org. And code.org worked with another big computer science organization, and they created something called AI for K-12. Okay, so you should Google this. And they talked about what AI means to them, and they start off with perception. Computers perceive first, then they learn about representation, and then they learn about learning. Then they learn about how to be agents and everything around the society. So the societal cost is what you're ultimately solving for. So, the social sciences is a very important piece, but also how do you actually deliver, help people understand about it? So the College of Education is a leader in that, in working with teachers. What can we collect? What can we not collect? There's IRBs and things like that. So we have Nancy, who's going to talk about what's going on in the College of Education in this space.
Thank you. I'm Nancy Hollandchek. I'm a professor or associate professor in the College of Education. I direct a program that is for current classroom teachers, and we created a graduate certificate that was just approved last week for teachers. And actually, it's for educators more broadly, but our target audience is K-12 educators. And we're really looking at developing their AI literacy, and in so doing, developing K-12 students' AI literacy, with the idea that we can start with our pre-service teachers as much as we are able to, but so many of our teachers are already in the classroom, and they really do need support and opportunities to learn. And so our 15-credit graduate certificate will be launched this fall, and it will focus on really developing teachers' critical AI literacy, which is not just understanding how to use AI, but when to use AI and when not to, and also really understanding what the perils and the problems might be, when to be cautious about interpreting what AI gives you. And another part of the program, and I want to give credit to Dr. Jared Borup, who's in the audience, is really focused on design and developing teachers as designers, using AI and developing tools with AI.
So thank you for reaching the biggest profession in the world, teachers. Right? So it's very, very important because, helping them to not only enhance their own pedagogical practices, but how to actually integrate AI into the curriculum is super, super important. And as you actually, each of you, and anyone can, you can go in any order, as you were designing each of your programs in terms of the curriculum, how did you balance how much theory, how much application, how much real world relevance, and and then of course the instructional decision that somebody has to make that's teaching the class, and the training that goes with it. You could pick any of these things that I asked, so in whichever order. So go ahead. You can start. We can go backwards. Yes, Nancy. Yeah, for the 15 credit certificate. So.
Sure. So I'll say for teachers, we're really very focused on relevance, right? On applications in the classroom. I think theory undergirds what we're doing in terms of really understanding that the teachers that we're going to be seeing first are those early adopters who are interested and excited, but in the long run, we also need to be figuring out how to convince those that right now don't see that they have time, or those that have some anxiety about it.
That's great. And Pat talked about the 15-year-olds that are tested every few years. It's called PISA, Program for International Standards and Assessment, given by the OECD. And lots of us work with OECD. And the next round of testing that's coming, actually in the mathematics exam, has two new components: block coding and computational thinking. Okay, so just wanted to let you all know if you did not know that. So it's very important to bring that much early into the school system. Others?
So from technical point of view, in our program, a master's in AI, so what really modern AI is, it's a combination of old math and new engineering hacks and tricks. And we have a program that tries to balance both things. So the old math goes back to Kolmogorov and Shannon and Bernoulli and Newton. So all of those things that they developed, some of them hundreds of years ago, are used in modern AI systems. And those things hasn't changed and not going to change. The basics, we teach them probability, statistics, calculus. And the new engineering tricks, they change quite often. But still, there are some very specific things like transformer architecture. That's a dominant architecture. It can change in 2-3 years. But right now, it is what's driving a lot of the token generation. And we have to teach that. And if it happens to be different technology in the future, we have to adapt. We have to change the curriculum and teach these things. So we have kind of two parts. One part doesn't change that much, and another part that updates it on a regular basis.
Wonderful. Thank you. And I think the latest and greatest techniques exposure is very important, and I'm sure you've heard of physics-informed neural networks, and which was actually developed by my student. Bert, Kolmogorov is back. There's something called KANs, Kolmogorov Adaptive Networks, which is competing with physics-informed neural networks. So knowing these things is very, very important for students. So taking those types of technical degrees is very important. Others, when you were designing, what are all the thoughts that, that went across?
So, you know, I think robotics, by definition, is going to be very hands-on. If you're going to build something, then you have to spend a lot of time in the lab in a very applied way. That is why you cannot find an actual robotics professor who believes that we're going to get humanoid robots as your maid anytime soon. I'm sorry to disappoint. So there's nothing like working with the technology hands-on to really have a real-world understanding. I would say, though, the way that I have taught over the years has changed. Whereas in the years past, I would focus really on theory, and then, you know, we would send people to the lab to try to get the real-world experience. I think the learning styles of people have changed with modern technology. And now I spend a lot of time mostly hands-on, and I try to sneak the theory in when they're not looking. Because they need the theory, they need to understand the theory to understand the bigger principles, but I think everyone is just, particularly in robotics, so excited to get going. I spend a lot of my time letting them make mistakes and really crashing a lot of robots, for example, and then standing back and saying, okay, now let's think about the theory, because if you understood the theory better, then you would have not made these mistakes in design. So, I mean, I'm sorry I'm teaching by failure.
No, that's great.
It seems like it's like a negative approach, but I do think that once you make that mistake for real in the lab, then you're probably not going to make that in the real world.
I'm so glad you brought failure, one of my favorite topics. And I know that people are sitting here thinking, I'm the world's greatest expert, so I'm going to have you fail right now in front of me. So everybody, put your hands straight, please. Put your hands straight, physical exercise. Put your right hand on top of the left hand. Right. Guys, right. Okay, right on top of the left hand. Turn your hands, grab your fingers tight. On the count of 3, 2, 1, you're not going to leave your hands. You're going to rotate your hands. You're going to turn your hands and open. Watch. On the count of 3, 2, 1, turn, open. Clearly, some of you are hungry. Actually, most of you are hungry. You're like, how did I fail here? Learn from failure, okay? I'm not going to tell you the answer. Maybe during lunch, get me. But work backwards, okay? So it's very important. So everybody has scope to fail, okay? That's the only way you can learn. So thank you for bringing that very important feature that we don't teach very well in higher education. So thank you for bringing that up. So others, just see, designing.
Right. So health informatics program is very specific because it's really interdisciplinary. And we have good number of students coming with clinical health type of background. We have some students coming with technical background and some confused ones that have no background in anything. So, you know, you can say that I'm a very classically trained computer scientist, and I do AI, what we refer to AI for probably 30 years or so. And then I teach students with those very different backgrounds. And to give you an example, I was teaching class right now, my advanced, machine learning in health class. And, I went a little too far and I started to talk about some embeddings in graph neural networks, whatever. And I see those blank stares. And I see, yes, I'm talking to a bunch of actually clinicians that have no clue what's embedding, right? And then you start adapting, right? You start thinking, because you have some students in the classroom who had several semesters of linear algebra, who had math, who had other things, right? And they get it, but the others don't. And they sit in the same class, and we talk about how to build those methods and apply them in health. And what we do in health informatics program, we really try to adapt. Because every semester is different. That mix of students with clinical background, with technical background, with other backgrounds changes. The way they're prepared actually changes. And we just keep adapting as we teach. And this is how the curriculum is built. I like to show technical things. I like to show how code works. I like to show other things, but not all of them actually get it. So we actually step back and we talk about the basics, right? Not the basics as the math, but more of the basics about the intuition, about different considerations of AI systems, how those systems really can be deployed, how they apply in healthcare settings, clinical, managerial, the others, and we just take it from there. So very adaptive approach to curriculum because the nature of informatics is like that.
Sounds like a great setup for a problem-based learning or a project-based learning when you have multiple participants with different expertise and all that stuff. But that also requires the instructor to be, well trained to actually be able to adapt and teach. And there's several sessions later on in the afternoon where you can actually learn about different ways to teach and all that. So, Jesse, ideas when you designed?
Yeah, I mean, I think that, I think that people often view the humanities and social sciences as kind of the most theoretical, right? And there's some truth to that. But I sort of learned when I was, early on as a father. I have a son who's now 20, but I remember bringing him when he was really little. He was a toddler, and I brought him to a museum, and I thought it'd be a great experience where he was going to learn all about dinosaurs. So he goes, and there's like a paleontologist, and paleontologist is just talking about dinosaurs. And I said to my son after how, that was great, wasn't it? He said, less talking, more doing, right? I mean, and he was really, really right about that. And I think that is the approach, right? So if we're thinking about what are the kind of things that underpin responsible AI, such as, for example, fairness, right? So we start with the theoretical idea of what is fairness, what does it mean to us, what are the different definitions of it, what is the theory behind what makes something fair or unfair. And then, right, we do less talking and more doing. So we roll up our sleeves and we think about how you put that fairness into action. And if you put it into action, right, at scale, like you can with AI, what are the outcomes, right? And so really it is a way of kind of rolling up one's hands and, playing with the theory.
This is fantastic. And the same OECD, PISA, those tests, do you know which country is on the top in reading, math, and science? Any guesses? A very small country. You can actually cover the whole end-to-end in 20 minutes, actually. Singapore. Now, Singapore, the National Institute of Education runs pretty much the, the educational policies and all that. They have a slogan. Many countries that do really well have a slogan. We don't have one in this country. Maybe we should do one. But the slogan for Singapore is teach less, learn more. The slogan for Finland, which is also on the top, is learning by doing. Maybe we should make ours test less, learn more, okay? So I know all the higher people are like, what is he talking about? So I'm going to ask Jared if there are questions from the audience. If so, can you actually ask from there?
One question we got was about the guardrails. They talked a lot about how misinformation is a real problem because once you learn it, you repeat it over and over and over again. So how can we set some guardrails to help prevent that?
Guardrails.
Yeah, I mean, I think that's a good question. I mean, I think that the first is, right, there are a few different ways. I'll talk about, I mean, I think that there are the technical dimensions, which I know in the Responsible AI certificate, Missy will cover, we have the class on design and deployment risks, so risk mitigation, and that focuses, on part on policy and part on the technical dimensions. But the other is to, view it as a matter of kind of a whole society approach with respect to what policy entails. And so currently we have a kind of vacuum of existing policies when it comes to misinformation and disinformation. There were some Biden administration types of steps that have been since rescinded and dialed back. But really it is a way to, the first is going to be, what does the law say, right? How do we respect the constitutional right to free speech in a free and open society? What policy derives from that law? What type of guidelines and approaches can we take that could inform the technical approaches that can then be developed?
Wonderful. Others? Guardrails? Obstacles?
So within the K-12 world, I think there's a lot being talked about how to do this. In our conversations with school districts in the area, we're hearing that they've got specific tools they're bringing in that kind of provide those guardrails for students, but those guardrails don't exist when they go home, right? And so I think a lot is about that education and having our teachers as well as our K-12 learners and really everyone understand the biases that are inherent in AI, to some extent understanding why that is, right? That the idea that these AI models are trained and what goes in does come out somehow. And then really relying, while also modeling for teachers, but relying on them to really bring that to the classroom and hope that we're developing understanding of the limitations and the dangers, while also recognizing the real need to use and apply AI in education.
Wonderful. Any other comments? Vadim, yes?
There are quite a few technical solutions for guardrails.
You're always technical, so.
Well, for example, LLMs, they write code to answer some of the things. So in code is verifiable. So you can go line by line and see exactly what code does and how it does it. And LLM, instead of trying to calculate it through one token at a time calculations, they write a code, run this code, and generate output for you. And there are quite a few of technical solutions of that sort. But I think at the end of the day, the human judgment, so human, the consumer of those tokens, is going to be the judge of the results and what to do with those results. And I think it's not going to go away. So human still has to be there and be the final guardrail of what to do with those generated tokens.
Thank you for bringing that up. So, any other comments? If not, we can go to the next question.
Yeah, we just got a question that I thought about too. Most students are coming into our classes with previous experience and perceptions of AI. Some love it, some hate it. And so how have you considered any type of bias assessment or discussion to kick off the program to begin conversations of AI by knowing where students stand on it?
Did you actually interview people before, as you were designing, like ask students? Yeah?
I have a story about something that happened recently in a class. I was trying to teach the class some of the basic statistics that underlie what's happening and how to specifically think about statistics in test and evaluation. And after the class was over, one of my students asked to see me privately. And the student basically, it was a kind of mini crisis for the student because the student said, I'm supposed to know this stuff in my job, and I just sat through your class and I realized I really don't know anything. I don't know what I'm doing, and I think I might be doing my job wrong. And he was in a job that was in a safety critical system, meaning people could die. And so we talked about the journey that the student could potentially go on to fix this gap. I was very, very impressed that the student felt the need to do that. And I really just want to underscore, and it kind of speaks to what Jesse was saying, and of course I'm going to say this as the director of the Responsible AI program. It is so important to teach both the technical side but the socio-technical side together, because I'm not sure if we'd been in any other class, the student would have had the presence of mind to say, I don't know this, and I'm also going to do some damage if I don't fix this gap. I don't think, you can do all the assessments in the world that you want, but if the students themselves do not feel like they should fix it, they need to bring themselves to the table to actually learn it. And we need to make that an educational environment such that they want to bring their issues forward.
This is such an important point. 65% of the people who claim to be data scientists are cleaning data every day. And most of the complaints from chief data officers is like, these guys are just doing drop-down boxes. Like, should I use random forest? Should I use this? Oh, it works. so they don't know why they're using what they're using. So I think this is a very important thing, and it could be a life and death situation. So it's super important that they at least have a foundational understanding on why they're using a certain algorithm and all that. So
Let me say something. So I think if we ask people here in the audience what actually AI is, we'd get probably like 50 different answers. And what used to be cutting edge AI 20 years ago, it's built in refrigerator right now, right? And the problem is when they come to class, right? When students come, they think of AI mostly as Gen AI, the way most people think, but there is so much more. The times when I started working on AI, it was mostly logic-based and rule-based machine learning systems and so on, right? This stuff is pretty outdated right now, but those systems actually are built in many, many, many places. And one of the things we do when teaching students is actually remove all of those misconceptions about AI. I have my own definitions. I define it more like a field and set of tools, and I'm pretty consistent with what Missy actually said before. But for lots of people coming, AI is this magic thing that talks. It's more like an AI in science fiction movies, right, than anything else, than actually set of tools that we build to solve very specific problems. And this is what we need to teach students, actually, that, define what that thing is, and that what's defined as AI actually really changed over the past years because the technology changed.
Love it. The messaging is changing from here is the AI, go solve the problem, to here is the problem, let's find the AI to do it, right? So which AI should we be using, right? So that's very important. So one last comment, and we can go to the next question also. Yeah, just.
Yeah, I have just a practical way that I sort of take the temperature of my students and to kind of see where they are with AI, and that's to begin the class. The first class is to kick off the co-creation of a class policy in the syllabus of permissible use of generative AI, right? And we write it together, and I provide some guidance. But by the end of the first week, maybe first week and a half, we have a student bought-in, generated, generative AI policy, right? And so that's a really simple way of shaping understanding what they think of as permissible use, so on and so forth.
And you learn also where they come from.
Exactly.
That's another thing as an instructor, and you're giving student ownership. That's great. Nancy, if you want to make it quick, we can go to the next question also. So.
Just saying that same idea that with teachers, that idea of negotiating, essentially it's another way of adding guardrails, right? Of negotiating within the class for them, and then also encouraging them to do that with their K-12 learners.
That's fantastic. Jared, next one.
Yeah, so we've had a couple questions here that are similar, so I'll combine them. But they're asking for the panelists to elaborate a little bit more on challenges of teaching about AI safety, security, health risks, algorithmic bias, and particularly for K-12 students. And how have we addressed that at Mason as well?
Anyone?
So we have an assignment that Jared shared with our faculty that's really a bias audit. One of the parts is having students collect images from the internet. If you go in and have them put in what is a picture of an engineer, right? What is a picture of a scientist? And as a STEM educator, that's where I land. But students very quickly see that it doesn't look like the people in this room, right? That the pictures that AI generates tend to be the traditional image. And so I think getting students to start with those images and really thinking through can be then a way to open that up.
Great.
I want to build on that and say I think these are the most common forms of bias that you hear when you hear about AI, but there's a significant, broader problem across all of AI, not just generative AI, all of machine learning, anything where there's a neural net. I do not think people understand about all the subjectivity that goes into the building on these models on the part of the builder, who is a human, probably a group of humans. For example, at big companies, there'll be one group of humans that maybe build the model. Then later, another group of humans will provide and update the hyperparameters. And another group of humans later are going to interpret what's coming out. There is massive, massive subjectivity going into the building of these models. These models are not objective. The way that the hyperparameters, for example, are tuned reflect a much deeper bias than people realize, which is why it is so important for people to, when they're getting these degrees, understand that the construction of AI is hugely socially driven. And I would propose, I have a student graduating with their PhD this month, I would propose to you that if there were the rapture of AI models that were built on bad assumptions, and all models just disappeared that were illegitimate, there'd be like 3 left on the planet. So I think that we as a community need to come together and understand the building of these models are not objective. And yes, the selection of images, that's just one bias, but that's the tip of the iceberg. If you look at below the waterline, the other sources of bias are significant and far deeper.
Thank you. Yeah?
Yeah, let me say something here. So, we take data, we predict data, and we claim it has anything to do with real world, right? And this is what's happening when, for example, lots of my work is in building models to predict patient outcomes and those things from, medical data. And we don't observe patient, we observe data. We don't even observe the outcomes of the patient, we observe the data. We build a model, we calculate all the accuracies, we do all the tests, everything looks great, but it probably has nothing to do with the actual patients, right? And so the problem is much broader. We like to talk about responsible AI, we talk about biases, we talk about other things, but it's really about going back and figuring out why do we build those models? Why do we do those things? What problems they are supposed to solve? And until we really understand this relationship between the data, between the problems we're solving and the real life, we'll be just building more and more models, and none of them actually do what they're supposed to.
Wonderful. Both of you commented on the word model. A famous British statistician said, all models are wrong, but some are useful. And I have a better one. All models are wrong, some are more wrong than the others. Okay, so that's my philosophy. And so this is very important. And some of you may have heard of this thing that happened at MIT Media Labs, where a student, they all got a facial detection algorithm, and they would sit in front of the computer and it'll actually tell, like, you are Peter, you are Mary, and all that stuff. And then when she sat down, she was African American, unlike everybody else in the lab, and it didn't say anything. And she was suspicious, so they went to a conference, I believe in Shanghai, and then there's a robot that walks to each one of them and said, good morning, and it starts to talk to them, and the same robot walks to her and keeps quiet. Talk about algorithmic bias. If you have not seen this movie, it's on Netflix. It's called Coded Bias. It's about joy. It's one of the most famous one. Please watch this tonight as a homework, okay? So one last question we can take. Very quick answer. Actually, you know what? It's 59 seconds. So why don't each of you give a closing 15 seconds to 20 seconds remark. Jesse, go ahead.
Thank you very much. I appreciate being here.
Oh, that's great. That's a perfect one.
So I'd say that AI is really cool, but we just need to do it right.
Okay, great. Missy?
AI doesn't think, it doesn't know, it doesn't understand, it doesn't reason, it just predicts the next token.
That's great. Okay.
I want to add, you should watch AlphaGo movie as well.
Okay. What's that movie? Yeah.
It's about this basically working of machine and humans together. Garry Kasparov lost in 1997 to a machine. He's been talking about this. He has a book on that as well, so how humans and machine work together. All top chess players get trained on machines nowadays. And I think everybody in this room will go through the same experience working with machine, whatever you do.
Netflix, Coded Bias.
And my last, I guess, is AI is coming, right? We need our teachers and we need our K-12 students to be critical users, right? And not to be afraid and not to embrace it too much.
Okay, so let's give a big round of applause to these panelists.